Now that you know how to send sensor data from your Arduino to the Helium network and then to an external consumer like request bin, and also you know how to update local configuration variables of your Arduino application from your Helium dashboard, there is one more thing that I'd like to show you, and that is to show you an application that is kind of closer to what a realistic Internet of Things custom web application might look like. So at the moment, we've got our gadget sending its data to request bin like that. That's the latest set of data. And the URL where that happens is right up there for the request bin, and that has been configured. We did this earlier in our channel settings. Right here in our HTTP Helium test channel, and that is the location, that is the URL where this particular channel will send its data using the post method. What I've got is a little application that is running on the Heroku host. Now, this is probably the topic of a whole new course on how to do such a web application on Heroku using high-level language like Ruby with a very lightweight framework like Sinatra. But I think it's a useful demonstration just to show you what the power of the Helium network is to be able to work with all sorts of different types of applications, including custom applications. So Heroku is a very easy to use platform that takes care of a lot of the problems that traditional web application hosting has to deal with, and that includes things such as provisioning servers and dealing with operating systems and patches and uploads and things of that sort. And what we've done is that we've written a little application that is available for you to play around with. You can look inside the course repository and let's get to it. It is this one right here. So 2348 Helium Sinatra web service example. You go in here. So this is the application, but the file that you need to look at that contains the actual application, the rest are just tests and some other helping type files, is this one here, te helium_demo.rb. In here we've got an application that is using the Sinatra framework, and it allows us to respond to particular types of requests. So for example, if you go to the base URL for this application, then you'll just get this message out. Actually, let's do that now. So we can go back to the Heroku console and I click on Open App. You can see that it brought up a new tab and it's calling the application now in its base URL. And there's a little message. This is the Tech Explorations Helium demo app, which is exactly what we put inside the double quotes here. In our case, though, we want to do something a little bit more interesting, and that is we want to send a post request to the application so that it can record the comma delimited formatted data that we are sending across. I've got a bunch of endpoints here. We've got Helium receive, we've got get Helium last value. This is a post request as well. It will respond to post requests, but it's able to decode a JSON message instead of comma delimited values as we are. I'm going to scroll down a little bit more, and right down here you'll see that we are making a post call, or we are responding to a post call. This is HTTP post Helium receive CSV. So this is going to read the body of the message that the Helium network is sending it. And when we go back to the request bin example, see how it says here, raw body. Well, this is the only content of this body. So the Sinatra application is going to grab the bit of text that I've got highlighted, and it will read it and store it inside this local variable. And then it's going to use this split function in order to break it down into little components, as those components are delimited by the comma character. And then we'll be able to, so this is a little array here. Then we're able to construct a new piece of string that we will store in a local text file that is also hosted on Heroku. So we're not storing anything in a database or in something else that's fancy. It's just all text files. So we are grabbing the current time, put a little bit of space and a hyphen, a bit more space, then the word temperature with a couple of dots, and then we're saying get the value stored in the first cell of the data array and print it out here. And we do the same thing with the rest. So all this text is stored now in the local variable data underscore new. Then inside the begin, right under the begin keyword, we've got a block here. We open up a text file and read it. And then we've got some file management happening here because we don't want to exceed 100 lines of stored content in this text file because of various Heroku file system limitations. So we don't want this to become a gigantic file. We only want it to store up to 100 files. And then the next few lines, I don't want to go into the details because Ruby and Sinatra is a whole different topic. This is just a quick example. But what we're doing in the block of text that I've got highlighted between lines 111 and 118 is to count how many lines we've got already in the text file. And then as long as we have not exceeded that 100 line limit, to add the new line at the top of the existing lines. And then in lines 123 onwards until the end of this method is to store the new set of lines back into the original text file. So the whole idea here is to not exceed the 100 line limit that we've self-imposed for our little data logging application. Of course, if this was a real life application, you could just remove that limit altogether and just constantly write into this text file without any limit at all. The latest record always appears at the top of this text file instead of appending at the bottom. A recap: in line 91, we create an endpoint that receives a post HTTP request that contains that comma delimited text that we want to store in our local text file. So back to the Helium dashboard. I'm going to go now inside the web app underscore CSV channel, and you can see that for the endpoint I have defined the Heroku application with the endpoint being the Helium underscore receive underscore CSV method, and I'm using the post method to send the data over. So let's try this out. I'm going to go back to my Arduino application, close that, and go to the beginning of the file. Right there. Oops, that's a bit too far. Comment out this channel name and uncomment the Heroku underscore web app underscore CSV. And that's the only change that I need to do. Now upload this sketch to the Arduino. Okay, so completed with the uploading. Now the Artem will start sending its data to the Heroku _web_app_CSV channel, you can see the data is already coming in instead of the previous Hello World channel. So there's the data coming in. You can check out the Atom debug log to see what the data looks like. And there's what the data looks like. Exactly the same payload as what we were sending over to the request bin earlier. And you can also have a look at the console, actually the logs on my Heroku app to see what kind of traffic is happening in the back. And you can see that we've got requests every few seconds coming from the internet, hitting this particular method using the post request. So there's a method, the post request method, and this bit is working. So we can see that there is traffic. So the next thing that we can do, one of the methods that we've made available is this one here, Helium get CSV all. So let's call this method and see the data that is being recorded. There you go. So this is the data that is being recorded, and as I refresh the page, we get more data coming in. You can also view the page source to see the raw data without any format, even though there is no HTML information there. But we can now see the raw data as it's coming in. And this page eventually is going to fill up to the 100 line mark. So what you've got here now is that Helium is sending the data from our sensors to our own custom web application. Now from here, what you do with the data is totally up to you. You can decide to send it, to forward it on to other IoT applications, like for example Tweet.io, which I'll be creating lectures on this particular platform a little bit later. But this is another option. You can also store your data in a database. If you're doing data logging, you can create charts and graphs. You can also have logic embedded. So if, for example, temperature exceeds a particular amount, then you can send a command back to your Arduino in order to switch on air conditioning or turn on a fan as a configuration variable. This is quite possible as well. So there's all sorts of things that you can do once you direct your gadget data to your own custom application. So I hope that this demonstration and presentation of the Helium IoT platform was useful to you. It gives you a good view of what a modern IoT platform looks like, and perhaps gives you a few ideas of what you can use it for your own projects. As always, if you have any questions or comments, please feel free to get in touch.